Hi, and welcome back to my channel. So this is a continuation of the previous episodes where I'm experimenting with this mixer. So in particular, to get more information about this mixer, have a look at episode 25 and about the setup that I organized here to measure things, the previous episode 26 and 27. So in this episode I'm doing something slightly different. So remember, from episode 26 and 27 I used that Siglent 1032X signal generator to produce the local oscillator as well as the RF signal. In this experiment instead I will use a real antenna to get the RF signal from the air, and the local oscillator is going to be generated by the HackRF. So this allows more possibilities because the Siglent is limited from 0 to 30 megahertz. Instead the HackRF can reach up to 6 gigahertz. So let me show you how the HackRF is configured right now. I'm using the, let me see if it can focus. I'm using the signal generator utility of the HackRF PortaPack, and as you can see it says here 438.9 megahertz. Okay, so this is going to generate a sine wave at 438 megahertz, 0.9. So let me start that, and you will see what happens on the spectrum analyzer. So let me actually activate the spectrum analyzer view, and let me configure the spectrum analyzer to produce the output. Okay, so that is the spectrum analyzer. I'm going to activate the RF as a signal generator, local oscillator generator, start, and let me see, it should be working right now. Yes, so let me change the frequency here, stop frequency, let's put 500 megahertz. And so yeah, the signal from the generator is there, is that little peak that we have indeed at 438.9 megahertz is there. Okay, right, so the effect of this is therefore that I will get in the output of the mixer in the IF port, which is going to an amplifier, which is then going to the oscilloscope, signals that are around that frequency. Okay, now I'm going to transmit here with this Baofeng set on low power on, as you can see, 438.9 megahertz, so which is exactly the frequency being emitted by the HackRF. And so the oscilloscope will receive the signal at the baseband, basically, and the output, this oscilloscope in fact has a port on behind where there is a copy of the channel 1, and this copy of the channel 1 is going to this frequency counter, this HP frequency counter, which will tell us which frequency we are looking at the oscilloscope. So let me now click and start a communication with the Baofeng. I'm going slightly away from the spectrum analyzer because I don't want to overload anything. So let's go. I'm now communicating, as you can see, and there we get the signal. As you can see, we get a signal on at baseband shown in the oscilloscope, and the frequency, I hope you can see, is 12 kilohertz, 800 hertz. And now if you have a look here, we are transmitting, and I don't know if you can see, but yeah, there is that N there. So that means frequency modulation in narrow channel mode, and the narrow channel mode is 12 kilohertz, 0.5. So that's exactly what we were measuring there, up to about 300 hertz of error, which could be due to several things, the clock here or the clock in the counter, and yeah, so it's the point is that the oscilloscope correctly measured the output of the Baofeng, down converted to baseband using this simple mixer, which it's incredible, it's amazing. And so basically the point of this video is that anybody with the HackRF, so the fact is that you don't need a spectrum analyzer or a signal generator or an oscilloscope to make this test, you can just use the HackRF, basically an antenna, and yeah, I'm visualizing the output with the speaker, the oscilloscope and the frequency counter. But you know, if you have a speaker, you can just connect the output to a speaker and you will hear basically a tone at 12 kilohertz 0.8. So yeah, it's pretty cool. I mean, it's a lot of fun to play with this mixer, and that's it. That's all for this video. So of course, if you have any comments, feel free to leave them in the section below. I'll see you next time. Bye bye.